Good day, I'm Peter Foy, Technical Marketing Manager with GD32VW553. Today I'm going to review the VW553. I'm going to show you how to get started using Wi-Fi 6 and BLE. For today's agenda, we're going to go through an introduction to the GD32VW553. I'm going to introduce you to the two different modes that it supports, and then we're going to do a quick BLE beacon demo. GD32VW553 supports both Wi-Fi 6 and BLE 5.2 under Wi-Fi 6, 802.11 BGNAX, and then we also support WPA3 in enterprise mode. Under BLE 5.2, we have a high-speed 2 meg and a 1 meg PHY. Long-range coded PHY includes both 125 and 250 kilobits per second support, and then we also support BLE mesh. Both the SoC version of the chip, and we also have modules available that support up to 105 degrees C. Memory consists of 256K of ROM, 320K of SRAM, and either 2 or 4 megabyte of flash. We also support coexistence, of course. You can have both stacks running, Wi-Fi 6 and BLE 5.2. We also support Matter over via Wi-Fi. So there's example designs of that in the SDK as well. So digging a little bit deeper, the GD32VW553, it is a 160 megahertz RISC-V machine with a double precision floating point unit. It supports both SoC standalone and NCP mode via UART. There are multiple power modes to reduce system power. You can individually power down either or the Wi-Fi or the BLE, or both at the same time. We also support target wake time under Wi-Fi 6. That increases efficiency as well and lowers power. And then under Wi-Fi 6, we support the OFDMA, the MIMO to increase network capacity and lower latency. We support Wi-Fi and station access point mode. Concurrently, we can support Wi-Fi and station with BLE instantiated, and then Wi-Fi and soft access mode with station support as well. Under security, we support secure boot and over-the-air updates. We have a secure key storage that is actually housed in the eFuse area of memory. And then we also have true random number generator. We have cryptographic acceleration units, hash acceleration units to support security as well. Peripherals include one USART, two UARTs, two I2C, one SPI, and one QSPI, along with an infrared ray port. And then one 12-bit ADC that supports 9 channels at 3 megasamples per second. All the SDK examples use FreeRTOS, and then we also have support for Azure Cloud connectivity in the SDK. IDEs that are supported in the SDK include GD32's GD32 Embedded Builder, as well as Sager's Embedded Studio. You can also use IAR or Kyle to support your designs as well. So the 553 can be supports two different modes. SoC mode. SoC mode is standalone. The application will run on the RISC-V machine as well as both stacks. In NCP mode, or network coprocessor mode, you have an external host that houses the application, and then you interface to the 553 via UART and send it function calls. So to get started with the developing with the VW553, I would suggest that you get the eval kit, download Embedded Builder. We also have, of course, a datasheet and user manual. There's also developer documentation that you can download. The Wi-Fi BLE software development kit's available, firmware library, and then demo suites are available as well. So we're going to go ahead and get started with Embedded Builder. Today's demo will show the 553 running in SoC mode. We're going to run a BLE demo, an iBeacon demo. The development system will be connected to the 553 eval kit via GD link. That's how we're going to download the software to configure the device. And then we're going to actually print back out from the UART to a terminal window. Okay, to begin with the demo, what I'm going to do is I'm going to show you where to download the tools, the SDK, etc. So you're not going to go to our main website, which is gigadevice.com. You're going to go to GD32MCU.com. You can go to the download section here. We're going to go over here and select the VW5 MCU, and then you can see where we have all the data here. You can have a data sheet, user manual. I'd suggest you download those. Most importantly here, we're going to download Embedded Builder today, and then also the SDK. So download those two files, and then you can join me in just a minute. After you download and unzip Embedded Builder, you can put it under program files. That's what I've done here. There's an addition that you need to make to the toolchain. So to compile for the BLE Wi-Fi SDK, you're going to need this Nuclei Toolchain. So we need to go get that next. So the URL for that Nuclei Toolchain is nucleisys.com, download.php. We need the RISC-V toolchain here, and under Windows, we don't need the latest one. We need version 2022.04. So we're going to download that. Okay, after you download that, like I said, unzip it, and then you're going to put it in that tools directory under Embedded Builder. I have downloaded the SDK and I'm unzipped it here in this directory. So I would suggest that you do that next. Okay, so we're going to go ahead and go into Embedded Builder. I have a shortcut on my desktop. We're going to go into the other directory. Start fresh and new. Okay, we're not going to go into the mutable bootloader directory, but the MSDK, and then again, there's a complete project here. That's all inclusive. We're going to go under the examples directory, go to BLE, peripheral, and then we're going to select the iBeacon project. But first we need to do is select this as our workspace. So we'll go ahead and launch Embedded Builder. Okay, next we're going to go into File. We're going to import that iBeacon project. So I'm going to select that folder. I'm going to select Finish here. Let's close this splash screen for Embedded Builder here and open our iBeacon project. So let's go ahead and take a peek at main.c and see what we got going on here. So we have debug print instantiated here. We're going to print a little bit of stuff back out to the serial port. Okay, so at the top of the header file, what they've done here is they've used company ID as Apple. The data length is here, and then we're going to, the beacon's going to send out this data. All right, let's look at a couple other things here. We need to make sure we have the correct platform selected here. So we're going to open up the config under platform development. We need to make sure that we have the eval kit selected. We do. So that looks good. The other thing that we need to do, we need to make sure that we have the correct tool chain selected. So let's go in here to settings. Under settings, we need to go to tool chain settings, and we need to make sure that we have the tool chain path set to that Nuclei RISC newlib library that we installed earlier. All right. So now we should be ready to compile. So we go ahead and right mouse click, select build. And this should take probably about 30 seconds or so. Okay, so we've finished building the project. So the next thing we need to do, since we've finished building the project, is we'll go ahead and we will program the board. So a lot of times you have to go into run configurations, make sure that we have selected the debugger here, and then we're going to select run. So this is going to give us a warning, says it doesn't know how to get the download address, to use the download function instead. If you use the download function initially, it's going to make you go back in and go through the same process that we just went through under run as, and then selecting the run configuration. So now we can go ahead and select download, and we're at 800,000 hex. Okay, so we can go ahead and download that into the eval board. Okay, now that we've downloaded our firmware into the eval kit, the next thing we're going to do is we could open up a tear term window because it's going to print some information back to the terminal. But let's go instead and go into show view and then select terminal. So under terminal, we're going to select it is COM4, baud rate's 115.2, select OK. So the next thing I'm going to do here is I'm going to reset the board. Okay, so we've reset the board here. We can see that in our COM window, it's initialized the radio, and then we're starting the BLE iBeacon example, and then we started advertising. So let's open up an application on an Android or iOS device. I'm going to be using an Android device. Okay, so I have my Android tablet hooked up here. We're going to go into the NRF Connect apps. So let's go ahead and do that. So you can see there are a lot of Bluetooth devices advertising in the area. But in particular, we are advertising as an iBeacon. It does not have the Apple icon because we do not have a license for it. So let's go ahead and dive into the iBeacon advertisement. So we can see that we did set our company ID to Apple. The UUID, we can take a peek of what we did there, but we set that UUID to 0 all the way through F. So that's what we have from 0 to F here. So you can see the major and minor data coming over here as well. All right, so that concludes our demo. We can see that the VW553 is advertising as an iBeacon, and we can see it when we scan the area for BLE devices. So again, this is Peter Foy. Thanks so much for joining me today.